So hello, assalamu alaikum. My name is Azman. Today we are going to discuss about the physics, and the topic is projectile motion. So this is the part two, and I have uploaded part one. So if you haven't watched that video, please go and watch that first. So today we are going to discuss about the further details regarding this topic. So in the previous video, I told you about the two-dimensional plane and about the friction, gravitation force, and constant velocities, x and y, and every single thing about the planes. Okay, but now the other thing that we are going to do is the shape. For example, that you have the circle, you have square, you have triangle, you have rectangle. These are the shape. So remember this thing, that this figure has also the shape. For example, if you are having the any projectile plane like from here to here, and another plane you are having from here to here. Okay, if I ask you which one is greater, so you will say this one is greater, means it is called elliptical. It is called elliptical. And if I say which one is small, so you will say this one, so it will call hyperbola. All right, so this is the name of the shape. The kind of you can say this is a half circle, this is a full circle, this is a half circle. So the small circle will say hyperbola, and a big one circle will say elliptical. Now other thing is that if I ask you that as you know that this is a path of the projectile motion. All right, so what does it call, like what do we call this path? So this path is called like oblique projection. Oblique projection. Remember one thing, that oblique projection only you will say this thing oblique projection when there will be a theta angle. Theta comes if, for example, if I talk about the certain height, if I just talk about certain height, and if I ask you that if you throw a ball from the building on the ground like this, on this plane, so there will be a does this path called oblique projection? Obviously not, because there isn't any angle. There is angle, but we'll not consider that because you are directly throwing from the y direction. All right, so that's why we don't call this one as oblique projection, but this one is definitely a oblique projection. Now the other thing that we are going to talk about is the determination of everything, every what we say, initial velocity, final velocity. So the initial velocity will be is equal to, firstly we have to draw the diagram of the projectile motion like this, and here will be the angle. All right, this is y, this is x. So if you know the composition of what we say composition, so you will say that this is Vx is equal to sine sorry cos theta, V cos theta. Okay, and Vy is equal to V sine theta. We represent these planes as Vx and Vy, and this point means the initial velocity will be called V naught. All right, V naught. And if you talk about the this one direction, this one area, so we'll just say V. This is the final, you can say final velocity. Final, this is the initial velocity, initial. All right, and every point we'll just consider Vx, V naught, Vy like this something. Okay, if you have the if you just calculating anything in the y direction, like here to here, here to here, so you will consider this thing as V naught x. All right, this telling you. All right, now the other thing that we have to know is for example, if I throw a ball with the velocity of 15 meter per second, and it will go to this direction, and it will be zero. I have told this thing why it is zero in the previous video, so go and watch that video first, then come here. So if I throw with the 50 meter per second with the velocity of, so there will be a velocity will be zero, and if it will come back, so the velocity will be the same. And what will be the gravitational force? In the previous video we discussed that acceleration will be zero. Okay, acceleration will be zero, means the ball will come with the velocity of 9.8 meter per second, because in the previous video we discussed that the two forces are acting on this structure in this topic. All right, which is gravitational force and air friction. So we just neglect the air friction because of some reasons, but we consider the gravitational force. So that's why we are putting 9.8 meter per second. So yeah, this was the reason. In the next video we'll discuss the formulas and derive all the formulas of the projectile motion, hopefully. So meet you in the next video.